Hey there, Mrs. W here. I'm going to show you just a few key features. We're going to compare the functions with tables and graphs and get an idea. So I'm going to give you a basic foundation here. The best way to learn this is to practice, of course, but let me introduce a few key features. Next unit, we're going to talk about key features and depths. But you should already know the x-intercepts, y-intercepts. So make sure, I'm assuming you do because that's like some basic. X-intercept, your y value is always going to be 0. So whatever your ordered pair is, your x, you're going to have your y value 0. In your y-intercept, the x value will always be 0. So whatever, let's just call it x, and we'll call this y. So just things to remember, being able to identify those. What you may see in a question, though, you may see something like, compare which value has the largest x-intercept, or what is the x-intercept compared to the other one. So you may have to do some subtraction. Just read what the problem says. But if you can identify the x and y intercepts, you are fine on that. What you need to also be aware of is relative extrema. So there's a relative maximum, and that maximum is the highest point on the graph, and it looks like a hill. So in our first example here, this is the relative maximum. You can have different kind of curves in your graphs. The highest one is your relative maximum. So with that being said, our lowest one would then be our minimum, or our valley. So trying to picture things to help you remember. If you get a picture, sometimes it's easier to remember. So looking at this graph down here, I'm sorry I cannot make it larger. I'm trying to, but I can't. So looking at the points here, the point -2, 3. So here is my relative maximum. Here is my minimum. These graphs in of itself, if it was just one graph, this is your vertex, this is your vertex. So let's talk about vertices. Vertices, or vertex, is where the graph changes direction. Your point where it changes. You're going to have a maximum or minimum. Again, like going up is your max, going down, your U-shaped, is your minimum or valley. So how can we compare these two graphs here? I've got f of x and g of x. F of x is my green graph on the coordinate plane, and my g of x is just a table. Now it says compare vertices. So first of all, let's find the vertex. So the vertex in this graph would be 1, 5. So you've got 1, 5. The vertex in your table, well, that's a little bit different. So I'm going to have to look at values and just kind of think through with the information that they've given me. Now, noticing my x values, they are starting small and they are getting larger. So my x values are actually going up. But what's happening to my y values? Now your y values, remember, is going to be like a vertical. It starts really large, like at a 107, and it goes down to 26, to -1, and then notice it starts to go back up again, and then back up higher. So these are the same distance. So it kind of looks like this right here. So given the graph, where does it change direction? Where does the point that they give you? So this vertice is a 4, -4, -1. This vertice is a minimum. And then on your f of x, because it's going up, looks like a mountain, this is your maximum, or it opens downward. So comparing these vertices, you may say something like g of x has a minimum where f of x has a maximum. Or, there is no minimum or maximum, whatever the question's asking. So comparing vertices. Now, if you didn't know, you couldn't figure out this table, okay, you're at a loss. Remember, you can go over here to Desmos and you can put in those table values. So I didn't write down the question, so I have to look it up again. So I've got 3x plus 4 squared minus 1. So I've got 3 x plus 4 squared minus 1. All right, so, okay, so remember you can just enter it however you see it in Desmos, but look, okay, so now I've got something. I'm going to zoom out a little bit on my graph and center it a little bit. So here you can see your points clearly. Well, right there is your vertice. You can see you can click on them. That's a negative 4, 1. And your maximum over here, which isn't letting me click on it, is a value right there. And we guesstimated that value right there. So we're fine. Now, comparing these, what if I take this negative away? Now I can compare these two graphs. And the question might be, which graph, and remember our red is f of x, green is g of x, vice versa, sorry. Which graph has the lower minimum? Well, looking at your graph, you've got a minimum here and a minimum here. So trying to look at there, I've got a negative 1, and you usually look at your y value, negative 1.06, so that's just a little bit over negative 1. So your f of x in this case would have the lowest minimum. So it's not going to be that decisive. You're going to be able to read the numbers better on problems. But giving you an idea how to compare, getting an idea what they look like. Again, you're welcome to use the Desmos if you can't get it from the table. And in the previous lesson, I showed you how to put a table in and create a graph from that. So I hope that you found this helpful, and let me know if you have any questions.